What if an airplane could look completely wrong and still fly? What if its wings were shaped like a pancake, its fuselage looked like a whale, its entire body was built around a giant cargo compartment, or one side of the aircraft looked completely different from the other? Throughout the history of aviation, engineers have repeatedly ignored conventional aircraft design in pursuit of better performance, greater efficiency, unusual missions, or simply an answer to a problem that seemed impossible to solve. Some of these aircraft were experimental machines built to test revolutionary aerodynamic concepts. Others were created because engineers needed to transport enormous pieces of equipment that simply could not fit inside a conventional airplane. And a few were so unusual that people on the ground reportedly wondered whether they were looking at an aircraft at all. What makes these machines truly fascinating is that they were not merely drawings on a designer's desk. Every aircraft on this list actually left the ground. Some completed hundreds of flights, some became operational aircraft, while others survived only a handful of experimental flights before their programs were canceled. From a 9-winged flying boat to an aircraft that looked like a giant flying saucer, these are 10 of the strangest aircraft ever built that actually flew. And make sure you stay until number 1, because the final aircraft looks less like a conventional airplane and more like something that escaped from a science fiction movie. Number 10.
Capronca 60 Transaero.
At first glance, the Caproni CA.60 looks less like an airplane and more like several aircraft stacked on top of one another. Built in Italy in the early 1920s, this enormous experimental flying boat was Giovanni Battista Caproni's ambitious attempt to create a passenger aircraft capable of carrying approximately 100 people across the Atlantic. The most extraordinary feature was its wing arrangement. Instead of using 1 or 2 conventional wings, the CA.60 used 3 sets of wings, each consisting of 3 wing surfaces. In total, the aircraft had 9 wings. The design was powered by 8 Liberty engines, arranged around the massive central structure. Rather than using a conventional landing gear system, the CA.60 was designed as a flying boat and was tested on Lake Maggiore. The aircraft was enormous for its time, and the idea behind it was equally ambitious. Caproni believed that a large, multi-wing configuration could provide enough lifting surface to support a huge passenger cabin while maintaining acceptable performance with the relatively limited engines available during that period. But the aircraft's unusual appearance was not simply an attempt to make it look futuristic. The multiple wings were intended to generate the enormous amount of lift required by such a large structure. And remarkably, it actually worked. The CA.60 made a brief maiden flight during testing in 1921. During its second flight, however, the aircraft crashed into Lake Maggiore and was severely damaged. The project was abandoned, and the dream of a 9-wing transatlantic airliner disappeared almost as quickly as it had arrived. Although the CA.60 never became a practical passenger aircraft, it demonstrated something important about early aviation. Engineers were willing to experiment with configurations that would look completely impossible by modern standards. And if 9 wings are already strange, the next aircraft took the concept of unconventional aerodynamics in a completely different direction. Number 9. The Avrocar. Imagine looking into the sky and seeing what appears to be a flying saucer. That was essentially the idea behind the Avro Canada VZ9AV Avrocar, an experimental aircraft developed during the 1950s. Unlike a normal airplane, the Avrocar had a circular shape. It was designed as a vertical takeoff and landing aircraft, with the appearance of something that belonged in a science fiction movie rather than an aviation hangar. The concept was developed in Canada and later taken over by the United States military. The aircraft was intended to explore the possibility of a high-speed VTOL machine capable of operating without conventional runways. Instead of wings generating lift in the traditional manner, the Avrocar used a circular central propulsion system known as a turborotor. 3 turbojet engines powered this system, directing air downward to create a cushion of air beneath the aircraft. In theory, this would allow the aircraft to hover and then transition into forward flight. The problem was that reality was considerably less cooperative than the engineers' calculations. During testing, the cushion of air beneath the aircraft became unstable only a few feet above the ground. As the Avrocar attempted to climb higher, it developed severe pitch and roll instability. The aircraft became extremely difficult to control, a phenomenon associated with the unstable airflow around its circular structure. Nevertheless, the Avrocar did actually fly. During free-flight tests, it could hover and move forward, but it never achieved the performance originally envisioned. Its maximum speed was only around 35 miles per hour. The program was eventually cancelled in 1961. The Avrocar never became a military aircraft, but it remains one of the closest things aviation history produced to a genuine flying saucer. It is also an excellent example of how a concept can look revolutionary on paper while exposing serious aerodynamic problems once engineers attempt to fly it. And the next aircraft solved an aerodynamic problem in a way that made it look almost impossible to balance. Number 8. The Blohm & Voss BV-141. There are symmetrical aircraft, and then there is the Blohm & Voss BV-141. This German reconnaissance aircraft from the Second World War may be one of the most visually unusual conventional airplanes ever produced. Its cockpit was positioned in a large nacelle on one side of the aircraft, while the engine and main fuselage structure occupied the other. The result was an airplane that appeared to have been cut in half and then reassembled incorrectly. Yet this bizarre asymmetrical configuration was intentional. The German military wanted a reconnaissance aircraft that provided an exceptionally good field of view for its crew. Conventional aircraft designs placed the cockpit inside or directly ahead of the fuselage, limiting visibility in certain directions. The BV-141 attempted to solve that problem by placing the crew in a separate glazed cockpit offset from the main fuselage. The aircraft was powered by a single radial engine, while the unusual asymmetric structure was carefully designed to maintain aerodynamic balance. From the ground, however, the design looked almost impossible to fly. You might expect an aircraft with its weight and thrust distributed so strangely to constantly pull toward one side. But the aerodynamic forces were carefully balanced, allowing the aircraft to fly despite its unusual configuration. The BV-141 first flew in the late 1930s, and testing demonstrated that the concept was far more viable than its appearance suggested. Later versions received more powerful engines, improving performance further. However, the aircraft faced a major problem that had nothing to do with whether it could fly. The German Air Ministry had already selected the Focke-Wulf FW-189 for the reconnaissance role, and resources were increasingly directed toward other aircraft programs. Only a relatively small number of BV-141 aircraft were built. The BV-141 therefore became one of aviation's great examples of an aircraft that looked fundamentally wrong but was actually a functioning flying machine. And if the BV-141 looked strange because its fuselage was divided, the next aircraft looked strange because its entire body seemed to have become a wing. Number 7. The Vought V-173 Flying Pancake. The name alone sounds ridiculous. The flying pancake. But this strange circular aircraft was a serious attempt to solve one of the biggest problems facing naval aviation during the Second World War: how to make an aircraft capable of extremely slow flight and very short takeoffs and landings. The Vought V-173 was designed by Charles Zimmermann, who believed that an extremely broad, circular lifting surface could produce remarkable low-speed characteristics. Instead of having a narrow fuselage attached to a conventional pair of wings, the V-173 essentially turned the entire aircraft into a wing. Two enormous propellers were positioned near the leading edges, driven by engines installed inside the aircraft. The idea was that the propellers could help control the airflow around the aircraft's wing and reduce some of the aerodynamic losses normally associated with conventional wingtip vortices. The result was one of the strangest airplanes ever constructed. It was almost completely flat. It had a circular body, and its massive propellers made the aircraft look more like a flying mechanical disc than a fighter. But unlike many bizarre concepts that never left the drawing board, the V-173 actually flew extensively. Its first flight took place in 1942, and over the course of testing, the aircraft accumulated more than 100 hours of flight time across numerous flights. Pilots discovered that the aircraft possessed surprisingly impressive low-speed characteristics. It could fly extremely slowly and demonstrated unusual control behavior without immediately falling out of the sky. The design even attracted the attention of famous aviator Charles Lindbergh, who flew the aircraft during testing. The Navy eventually lost interest as turbojet propulsion became increasingly important, and the larger fighter version of the concept was never developed into an operational aircraft. Nevertheless, the flying pancake had already proven its central idea. A flat, circular aircraft really could fly. And if that sounds strange, wait until you see an aircraft whose wing actually changes direction while it is flying. Number 6. NASA AD-1 Oblique Wing. Most airplanes have wings that point more or less perpendicular to the fuselage. The NASA AD-1 decided that this was merely a suggestion. The AD-1 was a small experimental research aircraft developed to investigate an unusual aerodynamic concept known as an oblique wing. Instead of sweeping both wings backward symmetrically, the entire wing could rotate around a central pivot. During takeoff and low-speed flight, the wing remained in a conventional position, extending across the aircraft. But as the aircraft accelerated, the wing could gradually rotate. Eventually, it could reach an angle of 60 degrees relative to the fuselage. The result was spectacular. From the front, the aircraft could look almost normal. From above, however, it appeared as if someone had grabbed the wing and twisted it sideways. The reason for this strange concept was aerodynamic efficiency. At lower speeds, a relatively straight wing is advantageous because it can generate substantial lift. At higher speeds, sweeping the wing can reduce drag. Traditional variable sweep aircraft, such as the F-111, F-14, and B-1, accomplish this by sweeping both wings backward. The AD-1 investigated another possibility: rotate the entire wing as one piece. NASA hoped that this could eventually lead to highly efficient aircraft capable of operating efficiently across a broad range of speeds. The small AD-1 was powered by 2 turbojet engines, each producing approximately 220 pounds of thrust. It was deliberately kept simple and relatively inexpensive so that researchers could concentrate on the aerodynamic experiment. The aircraft made its first flight in December 1979 and eventually completed 79 flights. Testing successfully demonstrated that the oblique wing concept could work, although handling qualities became increasingly difficult at extreme wing angles. At the maximum 60-degree sweep, the aircraft displayed challenging aerodynamic and control characteristics. The AD-1 program ended in 1982, but the research demonstrated that an aircraft did not necessarily need a conventional symmetrical wing arrangement to remain airborne. It was a small aircraft with a very strange trick. But the next machine was even stranger because its asymmetry was not an experiment. It was designed that way on purpose to make flying safer. Number 5. The Rutan Boomerang. Burt Rutan is famous for designing aircraft that often look unlike anything else in the sky. But even by Rutan standards, the Boomerang is unusual. At first glance, the aircraft appears to be asymmetrical. One engine is positioned differently from the other, and the fuselage and cockpit arrangement give the entire aircraft an almost unfinished appearance. But there is an important reason for this. The Rutan Boomerang was designed as a twin-engine aircraft with a particular engine-out problem in mind. On a conventional twin-engine aircraft, losing one engine can produce significant asymmetric thrust. One engine continues pushing the aircraft forward while the other stops producing thrust. This creates a strong yawing force that the pilot must counter using the rudder. Burt Rutan's solution was radically different. Instead of making the aircraft symmetrical and then designing around the engine-out problem, he created an asymmetrical aircraft from the beginning. The engines were positioned so that the aircraft's thrust characteristics could remain more manageable after an engine failure. The Boomerang first flew in 1996 and became a famous example of how an aircraft can deliberately abandon visual symmetry in pursuit of aerodynamic and operational advantages. The aircraft was designed around requirements similar to those of a conventional twin-engine light aircraft, but the unusual configuration allowed Rutan to explore the possibility of making a multi-engine aircraft easier to control when one engine was lost. And this is what makes the Boomerang so fascinating. It does not look like an aircraft that was designed by accident. It looks like someone deliberately challenged the idea that airplanes have to be symmetrical. The Boomerang proved that they do not. But our next aircraft took unconventional design much further, replacing the traditional airplane shape with something that looked like a giant flying whale. Number 4. The Airbus Beluga XL. Unlike most experimental aircraft on this list, the Airbus Beluga XL is not a failed experiment. It is a working transport aircraft that has performed an extremely important job for one of the world's largest aircraft manufacturers. And it looks absolutely enormous. The Beluga XL is based on the Airbus A330-200, but almost everything above the lower fuselage was dramatically modified. The result is an enormous upper cargo compartment with a distinctive rounded shape. The cockpit is positioned low and forward, while the massive cargo structure rises behind it. The aircraft's appearance resembles the head and body of a beluga whale, which explains its famous nickname. But the unusual shape exists for a very practical reason. Airbus manufactures aircraft components at facilities across Europe. Wings, fuselage sections, tail components, and other major structures must eventually be transported to final assembly locations. Many of these components are simply too large to fit inside a conventional cargo aircraft. The Beluga XL was designed specifically to solve this problem. Its enormous cargo compartment allows it to transport oversized aircraft components, including two A350 wings at the same time. The Beluga XL has a maximum payload of approximately 51 tons and a length of more than 63 meters. Its enormous cargo area is made possible by dramatically enlarging the upper fuselage while retaining the lower structure and aerodynamic systems derived from the A330. This gives the aircraft its distinctive whale-like appearance. The Beluga XL made its maiden flight in 2018 and entered service later as Airbus expanded production. Unlike the experimental aircraft earlier on this list, the Beluga XL demonstrates that sometimes the strangest-looking aircraft can actually be the most practical solution. But there is another aircraft that looks even more ridiculous when viewed from the ground. And it was built for an equally unusual transportation problem. Number 3. The Aero Spaceline's Super Guppy. Before the Beluga became famous, another giant aircraft was already carrying things that seemed far too large to fit inside an airplane. The Super Guppy was essentially a heavily modified aircraft transformed into a giant flying cargo container. Its history goes back to the early years of the American space program, when NASA needed to transport enormous rocket components. Moving these parts by road was difficult. Railways had size restrictions, ships were slow, and transporting giant components across the country could take weeks. The solution was to build an airplane with a cargo compartment so enormous that normal aircraft designers might have considered it absurd. The original pregnant Guppy was developed from a heavily modified Boeing C-97 Stratofreighter. Its cargo compartment was enormous for the era, with an internal diameter of more than 19 feet. The aircraft's bulbous upper fuselage created a huge internal volume while retaining enough aerodynamic efficiency for flight. NASA explains that the first Guppy aircraft allowed large space hardware to be transported dramatically faster than by barge, cutting certain journeys from many days to roughly 18 hours. Later versions, including the Super Guppy, became even more capable. The Super Guppy's cargo compartment is approximately 25 feet in diameter and more than 100 feet long. The nose can swing open, allowing huge objects to be loaded directly into the aircraft from the front. The aircraft uses 4 turboprop engines and can cruise at approximately 250 miles per hour. Its appearance is almost comical. The front section looks enormous compared with the wings and tail. The body resembles a whale, and the cockpit appears almost lost beneath the giant cargo structure. But this unusual design allowed the aircraft to perform a task that few conventional aircraft could even attempt. NASA has continued using its Super Guppy for oversized transportation, and the aircraft remains one of the most recognizable specialized transports ever created. The Guppy proved that if your cargo is too big for a normal airplane, sometimes the answer is not to make the cargo smaller. You simply make the airplane enormous. And now we reach number 2, where the aircraft becomes even more unusual. Because this time, the airplane looks like a giant flying pancake. Number 2. The Beechcraft Starship. When Burt Rutan and Beech Aircraft set out to create a next-generation business aircraft, they did not simply build another conventional corporate airplane. They created something that looked like it had arrived from the future. The Beechcraft Starship used a canard configuration, meaning its smaller lifting surfaces were positioned ahead of the main wing. It also used a pusher-propeller arrangement, with its engines positioned toward the rear. The aircraft was constructed largely from advanced composite materials, giving it a futuristic appearance while reducing the need for conventional metal structures. Instead of placing the engines on the wings or nose, the Starship used twin-pusher propellers behind the cabin. The configuration reduced some of the aerodynamic interference associated with traditional engine installations and allowed the aircraft to have a very distinctive appearance. The cockpit and cabin were positioned within a broad composite fuselage, while the main wing extended outward without the traditional tail arrangement found on most business aircraft. The result was an airplane that looked more like a futuristic spacecraft than a conventional executive aircraft. But the Starship was not merely a concept. The first full-scale production prototype made its first flight in February 1986. The aircraft eventually received FAA type certification in 1988. Its unusual composite construction, twin-pusher engines, and canard configuration represented a significant technological leap for the business aviation market. The Starship could carry passengers at high speed while offering a spacious cabin and a distinctive futuristic design. However, technological innovation did not automatically translate into commercial success. The aircraft was expensive to develop and manufacture, and the market for such an unconventional business aircraft was limited. Only a relatively small number were produced. Yet the Starship remains one of the most important unconventional business aircraft ever created. It demonstrated that composite construction, canards, pusher propulsion, and unconventional aerodynamics could be combined into a certified passenger aircraft. And that brings us to number 1, the strangest aircraft on this list. An aircraft that looked so bizarre that it earned the nickname the Whale. Number 1. Northrop Tacit Blue. If you saw the Northrop Tacit Blue sitting on an airport ramp without knowing what it was, you might assume someone had accidentally left a giant piece of unfinished aircraft construction outside. It has a huge, rounded fuselage, short, straight wings,
A V-shaped tail.
and a single air intake positioned on top of the aircraft. It does not look fast. It does not look aerodynamic. And it certainly does not look like a stealth aircraft. But the Tacit Blue was one of the most important experimental aircraft ever built for modern stealth technology. Developed in the early 1980s under a highly classified program, Tacit Blue was designed to demonstrate advanced battlefield surveillance and low observable technology. Its unusual rounded shape was intentional. At the time, stealth aircraft were often associated with sharp angles and faceted surfaces, most famously represented by the F-117 Nighthawk. Tacit Blue explored something very different. Could an aircraft with curved surfaces still achieve a low radar signature? The answer was yes. The aircraft's large, smooth fuselage was carefully shaped to control radar reflections. Its engine arrangement was also designed to reduce its infrared signature. Inside the strange-looking fuselage were advanced sensors intended to monitor ground activity and transmit information to commanders. The aircraft was aerodynamically unstable, meaning that it could not simply be flown like a conventional airplane using traditional mechanical controls. Instead, Tacit Blue relied on a sophisticated digital fly-by-wire flight control system. The computers continuously adjusted the aircraft's control surfaces to keep it stable. And remarkably, it worked. Tacit Blue made its first flight in February 1982 and eventually completed 135 flights over approximately 3 years. It accumulated more than 250 hours of flight time before the program ended in 1985. The aircraft was so unusual that it received the nickname the Whale. It was also sometimes described as resembling an alien school bus. But beneath that strange exterior was technology that would influence the development of future stealth aircraft. Tacit Blue demonstrated that stealth did not necessarily require a sharply faceted aircraft. Smooth, curved surfaces could also be engineered to produce a very low radar signature when combined with careful shaping and advanced systems. The aircraft was eventually declassified in the 1990s and placed on display at the National Museum of the United States Air Force. Today, it looks almost harmless, but its importance was enormous. This strange aircraft helped prove technologies that would influence the next generation of stealth aviation. And that is what makes the Tacit Blue such a perfect example of the strange relationship between appearance and performance in aviation. An aircraft does not have to look aerodynamic to fly. It does not have to be symmetrical. It does not need conventional wings. Can look like a pancake. Can look like a whale. Can look like a flying saucer. Can even have a wing that rotates sideways during flight. What matters is not whether an aircraft looks normal. What matters is whether the aerodynamics, propulsion, structure, and control systems work together. Throughout aviation history, engineers have repeatedly demonstrated that some of the strangest ideas can become reality once someone is willing to build them and actually take them into the sky. From the 9-winged Caproni CA.60 and the bizarre Vought flying pancake to the enormous Super Guppy, the futuristic Starship, and the secretive Tacit Blue, these aircraft prove that aviation has never been limited to conventional shapes. Some designs failed. Some became legends. Some transformed aviation technology. And a few became practical machines that are still remembered today. But every one of them answered the same question. Can something this strange actually fly? The answer, remarkably, is yes. If you enjoyed this video, make sure to hit the like button and subscribe to our channel. We bring you the most incredible aircraft, experimental airplanes, legendary aviation machines, groundbreaking aerospace technology, and fascinating stories from the world of flight. There are thousands of unusual aircraft that never became famous, and some of them are even stranger than the machines you saw today. So turn on notifications, because in the next video, we are going even deeper into the world of aviation's most unbelievable flying machines. Thanks for watching, and we'll see you in the next one.